Having that very good introduction already, I can almost skip the first two slides. So this is a platform engineering talk we are having now. And first of all, thank you all for coming. Hope you had a good lunch and feel energized, maybe tired. Who knows? After lunch, it's can be like this or like that. We already heard about ourselves, Hossein and Fabian, myself. We're working for Liquid Reply. There's actually an Italian Liquid Reply and there's a German Liquid Reply. We are from the German brand. And what we want to talk about is platform engineering. So we want to start with that. Why platform engineering? Which bottlenecks or which challenges platform engineering is trying to solve? So give you a basic understanding of what platform engineering is actually about. Then we want to talk about a bit how an architecture for a platform can look like. We will stay on a high level. And then we also want to talk about how Kratix and Backstage, these two tools, can help you in creating a platform that is actually providing benefits to the platform users. And we have also prepared a demo so you can see it in action as well. Okay, so let's start. I guess you know this kind of very traditional IT department setup. You have dev teams, you have ops teams, and dev teams, there will be a point in time where the dev teams will need resources for their applications. They might need infrastructure, so they will reach out to the ops team, and the ops team says, yeah, sure, I'm glad you asked. I will definitely do that for you, but I need to plan that into my sprint, and I have some questions. Can you please first answer them to me? And then eventually the ops team will deliver, and will deliver the infrastructure to the dev team. And don't get me wrong, this is all fine. This can work absolutely fine. I would say it's a lean approach. And if you have only very few dev teams that are approaching the ops team, and if the requests are also for not that complicated resources, this can still work out. So all good with that. But once you come to a point where you have more and more dev teams who are requesting resources from the ops team, or if these requests are getting more and more complex, or the resources that are requested are getting more and more complex, you will run into scalability issues. The ops team won't be able to fulfill all these requests in due time. So the ops team is actually becoming a bottleneck. So from that, the idea of DevOps evolved. So you kind of have the idea, why not bring these two teams together? So have dev and ops in one team, which sounds like a very good idea because it makes it possible for the individual teams to manage the whole SDLC, the whole software development lifecycle. So from start to the operational day 2, day 3, day 1000 of an application. And actually, I was so lucky a couple of years ago, I was working in a DevOps team and this worked. So there are situations where this definitely works. It worked for us as a team, but we were, of course, part of a company. There were multiple teams in there. And it worked for kind of a couple of other teams as well. But there were a lot of teams where this DevOps approach did not work because they didn't have the experience or the expertise in the team. So they reached out to us and asking them, hey, can you help us configure these and that services? And you kind of get back to that first approach of having a dev team and having an ops team. So it was, again, sort of a bottleneck in there. So the scalability is also an issue for DevOps teams. So you see that these approaches, they can work, but in the end, it does not work if you scale. So, and this is where platform engineering comes into play. So this is like the latest and hottest take on that topic and trying to solve all these challenges of bottlenecks and being able to scale in a company. So what is it? Let's define it together. It's actually sort of a discipline. You are building tool chains, you're building workflows for your platform users. So the platform is always for somebody else, for the platform users. Everything you do is for your users. And the good thing is that this platform is like an abstraction layer. It sits between the users who want to use your platform and the resources they need. And by being this abstraction layer, it's possible that all these requests can be basically responded on in a standardized ways. You can automate everything, which then helps you with the scalability issues. You can follow like compliance requests. Basically, you make sure that all the requests are handled in the same manner. And if you do that, and you should do that, basically creating the services of the platform in a self-service manner, then you're enabling your platform users to work autonomously. So they can use your platform without being you as a platform engineer being involved in that process. So you kind of want to limit that human factor in that whole process. And in the end, if you do it right, you will get to a situation where the development of applications is getting more and more efficient. So efficient in terms of costs. So if you have FinOps aspects in your platform, so it's getting more efficient in costs, security, best practices, compliance, even data protection. This is all where you can basically have standardized processes via a platform. So bringing this to into a visual representation of what I just said is, you have a platform and you have a platform team who is responsible for that platform. And the platform is the abstraction layer that is sitting basically in front of the services that a company has to provide for the development team. So you might have observability services, you might have operational services, can also have like QA services. And these services can actually be handled by specialized teams, because these specialized teams, they have the knowledge how to do it best. But the platform is sitting there to make these services then available to development teams. So the development teams, in this case, it's development teams, they are the users of these services via that platform abstraction layer. And well, we wrote here development teams because like building platforms for developers is like the most prominent use case in platform engineering, but it doesn't have to be only for developers. It could also be that you're building like a data platform or an AI, machine learning, whatever platform. But when we're talking about platforms for developers, the term you will also find in the literature is IDP, Internal Developer Platform. And for the rest of the talk, we will talk about IDPs when we're talking about platforms. Now, a platform for developers has to provide, of course, a couple of core elements that developers will need. One of them is, of course, they need to configure their application. The platform has to provide a service for them to configure secrets, to do versioning, things like that. So that's one of the core elements. The platform needs to provide, as we mentioned in the beginning, a way to configure infrastructure resources like networks, virtual machines, databases, and whatnot. So this is all handled by the platform in the end. Of course, you have environment management, because usually you not only have like one environment, but you have like a dev, maybe even a QA and a staging environment, and then also a prod environment. And all these environments have to be manageable by the platform. And then, of course, like how do you get your application to these environments? That's the deployment part. The platform is also helping here the developers. And of course, you have RBAC everywhere. So you need to make sure that the users can only see and can only touch basically these parts of the whole IT landscape that they are also supposed to touch. So you want to avoid that team A is, for instance, seeing observability data from team B. So this is something you have to take care of. And this is just a few core elements. There is, of course, a lot more. I mentioned it, like FinOps parts, security, observability, compliance. So the list can go on and on. So you see that a platform is not easy to build. So there's a lot going on. Good thing is they do exist reference architectures. This one is from platformengineering.org. It actually continues on the next slide. And if you're familiar with the CNCF landscape, this is maybe giving you CNCF vibes here. And I don't want to talk about these individual tools here. It's more like the big picture. What you can see here is that there are different planes. Here on the top, we have the developer control plane. And in these planes, you're kind of consolidating all like services and tools. And the developer control plane is where the developer is living. So you have things like Git, CLI, you have the IDE in there. And then another important plane is the integration and delivery plane, which is kind of the heart and the brain of the platform, because here you are defining your services, so basically the APIs, that are then consumed by the developers. So this is where the magic is kind of happening. And you see also there's a resource plane. The resource plane is basically containing all the resources that your platform is managing. Could be infrastructure resources, but could also be anything else. And if you have good eyes, maybe better eyes than I do have, then you might have spotted that Backstage is here living on the top in the developer control plane. So when we talk about Backstage later on, now you already know that this is a tool the developers will interact with. And we also have Kratix here, the other tool we want to talk about today. This is living in the orchestrator section or platform orchestrator section. So this is like where you are defining your APIs, which the developers later on will use. Now I said this architecture is continuing on the next slide. What you see here is like the monitoring and logging plane. I think it's better to call it observability plane. There's also a security plane. And what is a bit missing is like a capability plane, like managing certificates, managing secrets, all this kind of stuff, or managing DNS entries. This is a bit missing in this reference architecture. But now the good thing is there's not only a reference architecture, but there also do exist reference implementations. And there are a couple of tools out there. Canoe, for example, Hossein, my colleague, he has worked with Canoe already, and if I got it right, you are quite convinced by that tool as well. There's also something from Krateo, Kubevela, and Kratix. And we want to talk about Kratix today. I'm pretty sure that we from Liquid will probably take a look at the other tools out there as well. Now, what is Kratix? It's a framework, open source framework. With Kratix, you can build these composable IDPs. It's based on Kubernetes. With Composable, what do we mean with that? Basically, you can define individual parts of your platform, the individual services, and you can also combine them together. And there's a company behind that. The company is Syntasys. So if you have the need for an enterprise offering, there's also that. But I would say that the free and open source offering is already quite good that you're getting. Now, to understand Kratix, you have to understand the core concept of a promise in Kratix. So a promise is something the platform engineering team will manage. And since we are living in Kubernetes, a promise is a YAML file. So you are again end up with writing a lot of YAML files. The promise, the YAML file exists of a couple of different sections. The first section is the API section. The API section is where you are defining CRDs. So if you're not familiar with it, CRDs, custom resource definitions, this is how you are capable of extending the Kubernetes API server with your own custom logic. And so this is what the developers will later on use. So the developers will create custom resources, and these custom resources will then invoke the promise. Now in that promise, you can also define dependencies. A good use case for that is, let's say, you're creating a promise for an app. What do you need for an app in Kubernetes? You need a deployment, you need a service, and maybe you need an ingress. And then you could say as a dependency, you need to have an ingress controller there. So with these dependencies, you can make sure that in the cluster there's an ingress controller, and only if that ingress controller is there, then this promise can also basically do its magic for the other required files, the deployment, the service, and the ingress. Now the API is just basically the CRD, so custom resource definition, but the logic is living in these workflows. So these workflows are actually containers you are running, and you are writing these containers. So with these promises, you will end up writing Docker files and the logic for that, which means that you have the full flexibility, right? I mean, it's a container. You can do sort of whatever you want in that container and can use whatever language you want and can configure it up to your needs. And if these workflows are running through successfully, I mean, under the hood, they're just Kubernetes jobs then in the end, or pods. If they run through successfully, then the promise is also fulfilled, which is what you want in the end. And there is also the last section of destination rules. Think of this as if you as a platform engineer want to create a new service and you want to first test that out only on dev environments, then you could say, hey, please, this promise should only be able to work on dev environments. This is something you can do with these destination rules. So how would it look like in a use case or in a base architecture to understand that a little bit better? What you start with is a Kubernetes cluster where you're installing Kratix operator. And this is then, so Kratix calls that a platform cluster. I mean, you could also call it a management cluster, whatever. So you install Kratix in there, and you install the promise in there. So this is all the tasks that the platform engineers are doing. And now let's stick to that example of the app promise, where we say deployment, service, and ingress is required for a developer team. And if the promise is available, developers can basically invoke that promise by specifying a custom resource with the required input parameters that are specified in the CRD. Now what Kratix is doing, the operator is basically registering, hey, there's this custom resource deployed, this is belonging to this and that promise, so I'm invoking the workflows that are defined for that promise. And in this case, the workflows will just create output files like the deployment YAML, ingress YAML, and a service YAML. And Kratix will not deploy that stuff for you. So Kratix is just creating basically these files based on how you have defined it in your workflows. But what it will do is it will write it to a state store. So Kratix is working with a state store. It could be a Git repository or also an S3 style bucket, so MinIO or AWS S3. And it's basically, this is what Kratix is doing. It's doing what you're writing in the workflow, and it's creating output files and writing these to a state store, but it's not deploying your stuff. So this is where it's up to you how you kind of want to deploy that. And if you have something in Git, of course, the GitOps approach fits very nicely to that. So if you have like another cluster where you want to deploy your application, you could say you have Argo CD or Flux running in that cluster, or you can also have it running in your management cluster. That doesn't matter too much. But in the end, your GitOps tool will basically check the state store, basically pointing to the same state store, and deploy whatever files there are, or reconciling these files to the destination cluster. So you see that there's no direct connection from Kratix, from the management cluster, to the destination clusters, which means you can hook up as many destination clusters as you want to that setup, because they're, in the end, they are just pointing to the state store, and it's important to note that you can define also multiple state stores. So for each environment, like a dev state store, prod state store, whatnot, actually you can also define it for each and every team. Each and every team could get their own state store. So that's all quite flexible and quite easy to manage, I would say. And the question now is, if we come back to the first point, where the developers are invoking like these promises, how do they do that? I said that they can deploy custom resources to the cluster, but how does it work? I mean, some development teams, they are not knowledgeable of how to define a YAML file for a custom resource, and they do not have to be honest. And this is where now Backstage is actually coming into play, and Hossein will continue here.
Thank you, Fabian. Before jumping to Backstage, I'm sure lots of you are familiar with Backstage, one of the widely used open source frameworks. So I want to differentiate between the terms are used frequently, interchangeably. So internal developer platforms, that's what Fabian talked about, and internal developer portals. So platforms, we talked about it. They're highly focusing on mainstreaming, standardizing, internal workflows, processes, infrastructure as code, how we build these pieces of a platform bit by bit. So that's the focus of the dev platform. But the portals, it's about how we expose it, how we make it discoverable. This is a question I'm facing every day in a consulting job. I'm going to a customer, I'm asking, okay, what have you done so far in terms of cloud native? We built platform. It's so nice. We are offering all possible managed services in our company, and it's a complex setup. I say, perfect. So first question, how do you enable your developer to use it? How a developer journey looks like in your company? No answer, because they haven't thought about it. They don't know how to expose, make it easily usable by developers. That's where Backstage comes in. So Backstage is, as I said, open source framework developed by Spotify to manage their internal ecosystem. And a few years ago, they open sourced it, and later it was donated to CNCF. So now it's a CNCF project. It's, as I said, it's about discovery. It's about exposing what we have built internally. And it's a central UI, it's a central portal that we are going to expose our services that we have built. It can be a monitoring dashboard, it can be a CI/CD pipeline, it can be our Kubernetes cluster, it can be a service now that we are using for automating our internal processes. So it's gonna be the central interaction point for whomever is going to use the platform. So exactly as we talked previously, one of the main focus of Spotify, the Backstage is to expose the services and make it easily for end users to use it in a self-service manner. What does it mean? So as a developer, sometimes I don't need to really make myself so much busy with all the processes, workflows, bureaucratic stuff in a company. What I want in an environment that I can deploy my application and some of the few dependencies around it. So usually what happens, you write an email to your colleagues, or you create a ticket, which takes weeks, months, I've seen it. So this is the main focus of Spotify, to make it self-service. I just go to the portal. It depends on how you want it. It can be a few boxes. You just put some input, or it can be by CLI, or it can be API exposed. So up to developers. So, and with this way, we let them to focus on exactly what they need to, developing software and boosting the software development speed and the time to the market, and also decreasing the cognitive load. Lots of developers, they hate managing infrastructure. They're not interested. I'm talking to them every day, and they say, honestly, I don't know, and I don't want to know how my platform team is managing a Redis instance. I just want to use it. I'm just the end user. So let's look at how the Backstage is built. So it's three layers: plugin, app, and core. So the core is developed by the open source project. It's in let's say it's a software lifecycle. So the base project is offering some feature out of the box, like SSO, like some example applications that helps you to understand Backstage more. So, and then when you want to deploy the application, you have to deploy an instance of Backstage. So that's where the customization part starts. So you can change Backstage and customize it exactly to the needs of your company, your organization. That's where the plugin part comes in. So the plugins let the company to connect their existing services, platforms internally to be exposed via Backstage. So you connect them and you let them to be utilized by the end users. Later, I will talk more about the plugins, because it's the main and the core feature of Backstage. So let's look at the philosophy of Backstage. Why Spotify started developing Backstage. So it's, as I said, it's the interface, it's the UI. That's the power of the Backstage. So that's a central portal that you expose to your organization, and you let the developer to use, can consume the services that you have built and you are maintaining internally. It's about autonomy. So fun fact, the central instance of Backstage at Spotify is maintained by five people. Five people managing a central instance. But what is interesting, there are 100 teams inside the Spotify. They're developing plugins. So bring your own plugin and play. So you integrate your plugin and then you can use it. But it's not easy just to bring a plugin, put it into Backstage and start it. It's a software. It needs exactly software lifecycle management. So you need to develop it continuously. You have to continue maintaining it. So that's this 100 teams are doing inside the Spotify. So a few weeks ago, I was in a workshop with a customer. They asked me, we have 10 teams and you want to deploy per team a Backstage instance. I said, go ahead, have fun. I mean, 10 Backstage instances, each time you're gonna upgrade node version, yarn, you're gonna integrate a new plugin. Have fun with maintaining that. It's impossible. You need a central Backstage instance, but you need to build the community around it. The people who can develop the plugins and maintain it. So if you look at the Backstage ecosystem, there are three outstanding components. So at the core, we have the components. So that's how we define the Backstage the core elements. So the components can be a service. Let's say I'm offering managed Kubernetes service in my organization. That's how I can formulate it in Backstage language. It can be a library, it can be artifact, it can be a CI/CD pipeline. At the other side, we have the resources. These resources are mapping to real objects out of Backstage. It can be Kubernetes object, it can be cloud resource like managed services, databases, or a cluster, as I said. And the API, that's how the components are communicating. We can communicate using REST API, or we can use other protocols like gRPC. So we talked about Kratix, and we saw what Backstage can do. So how Backstage is fitting in whole this ecosystem. So Backstage gives you this seamless UI, this unified framework that you can utilize to consume the services, the capabilities that your platform has built for you. And either you're using CLI, you're using a UI or API, so it gives you all possibilities. On the other hand, we have Kratix that we used as a developer platform to build our complex platform bit by bit by using these small tiny pieces of platform, by integrating managed Kubernetes service, by integrating managed database, streaming platforms, all these services that the company needs. We let our platform team to declare them, in a semantic way. So this gives us a unified framework. And that gives us the experience to the both platform team and the developers that they both can work with the same API, which is Kubernetes. And of course, this way we can decrease the maintenance by letting the platform team to focus on building these capabilities and letting the developers just to consume it. So if we put Backstage with Kratix together, so we have such a architecture. So platform team is creating the components by writing templates and storing them in Git. And Backstage is able to read those templates from the Git. And when a developer communicates with Backstage, I want to create a Redis instance. What happens in the background, the Backstage translate that template into a Kratix promise. And as Fabian explained, this promise has a workflow, all the dependencies that my promise should have. Let's say I want to deploy a Postgres operator as a promise, and I want to create a Postgres instance. This is the workflow will do. It will install the Postgres operator for me. It will ensure that all the dependencies are there, and it will deploy it at the destination. So as you can see that, it can be a Kubernetes operator. In this case, it can be a cloud resource. So it gives you full flexibility to create your resources as you wish with the same YAML file. So with having both this tool, we can build a modular and composable platform. So at one side, Kratix focusing on building this complex platform bit by bit by using small tiny pieces of capabilities in a declarative way. At the other side, we have Backstage, which is the front end and the central portal that we can let our developers to consume the services we have developed internally. So I provided a small demo. I will just directly jump into my demo. I hope you can see my screen. Is it big enough? Okay. So it's not there. Okay. I will stop it. Okay, in this case, I will just let the next slide to show us what will happen. So it is exactly provided for such a case. So let's say I want to use Backstage to create, a service. So this is exactly what happens. I go to Backstage UI, and in this case, I'm going to create a Postgres instance by using Postgres operator. So imagine I'm onboarding a developer teams. So by creating this, I'm creating a namespace inside Kubernetes cluster, and I'm creating a dedicated Postgres instance by using the operator concept. So as you can see, it has already deployed it. This is how the component registered. And then if I go to the cluster, in the real cluster, I can see that a Postgres instance has been created. And then it will show the Postgres instance as a pod that is running. So as you can see, it's reconciling with the definition. So as you can, we can see that, it's already successfully initiated. So yeah, that's basically how does it look like from platform engineering side and the UI focusing for the developer. What is great about the Backstage, so I see that the main cognitive load for the platform engineering team is to create, the Backstage templates. So that's lots of people are complaining about. I have YAML files for creating my resources, but I don't know how to put it into Backstage language. That's where the plugins of Backstage are quite strong. There's a plugin called Kubernetes Ingester. So it translates your objects created in Kubernetes into Backstage language, basically into your software catalog. So that's where you can reduce the load of writing all those templates by yourself. Let's recap what we saw today. So I think creating such a modular and composable platform is important, because I see lots of customers or companies creating complex platforms, but honestly, they don't know how it works. They don't know which piece is communicating with what. So we can put more lights on that by creating such a platform. So it also helps the development teams by not focusing on the complexities on the infrastructure, but just letting them to consume what we have built internally by exposing it with UI such a Backstage. And Kratix allows us to focus on building that platform by the same API we use for the deploy our application, and use the same declarative semantic. As I said, the goal of whole story is that to enable developers to improve their productivity, and bringing new innovation, new technologies into our platforms. AI is really hyping these days. So Backstage can be really the central portal that we can expose in our companies. We can let our developers to use the services that we built for our companies. That's it.